Okay, looks like we're live. Hello, everybody. Welcome to our very first community development event for SEIP 2010. We are live and unscripted. This is going to be, suppose we could call it a live stream about the problem solving process that I personally go through as I work through a new challenge or problem, whether it be a coding problem, a math problem, or a life problem. I use the same process no matter what, and it applies very well to solving algorithm and data structure style problems. Before we go into anything like that, I'd like to do a little intro stuff first. We're going to cover three things first. One is just a quick icebreaker. The second is a hello. Here's a little bit of information about the guy who's going to be talking to you today. Who is this person on the screen? And then third, I just want to drop a little background information about the pre-course experience. This will take a total of, I don't know, maybe 10 minutes max, and then we're going to go straight into problem solving. If you see me fuddling around on my screen a little bit once I start to share, please be patient. I just moved from one place to the next, and I don't have my second monitor set up yet. So I'm working on just one screen, and we're just gonna make it work. Okay, quick icebreaker. We have a whole bunch of people in the room, 133 it looks like. Can I have everyone in the room go into the chat and just type in the location that you are in right now or where you are living while you're going through the immersive? Isn't that wild? First of all, they're coming in fast. Second,
holy crap.
I think it's really cool how we are all together in this moment. I mean, I know the internet's been around quite a long time, but I still think it's pretty amazing that we can all gather in one place together without having to be physically together. I know a lot of us want to be physically together, so do I, but I think it's pretty amazing what we can do remotely. And I think it's pretty awesome that people from all over the place are coming together to all kind of do the same thing. We're all coming from very different backgrounds to converge together for a brief moment in time where we will all study, appreciate, and strive for the same goal together before we all diverge outward into our own individual paths again. So on that note, let's now go to the chat and type in, what do you do for a living, or what field or profession are you in as you're transitioning into tech? I think this one's even cooler because we really get to see how different we all are in our backgrounds and how many non-technical folks are with us too, transitioning in. Astronomy, that's cool. Just a fun, quick thing to see and do. And we can do it silently with 130 people not unmuting. By the way, this is an after hours event. This is a very casual event. This is not a formal lecture. Feel free to kick back, grab a beverage, sip upon a glass, and enjoy. Okay, let's move into the next item. I'm going to share my screen. So who's this guy on the screen? Give me a thumbs up in the chat if you can see my my presentation. Okay, cool. Hello, everyone. I'm Anthony. I'm the program lead over here at the pre-course department at Hack Reactor, or Galvanize. I am a scientist. I'm an engineer. I am a technical mentor with this company for quite a while now, and hopefully we can become friends. I'm 31, which is okay, I guess. I'm recently engaged to a very nice Danish lady named Sophie. She's a medical doctor. She's at work right now, which is why I can do this in the middle of the night easily. I have lived in these places. I grew up in New York, did a year in Boston during college. After college, I moved to Silicon Valley. I also lived in San Francisco for quite a while I worked at Hack Reactor out there. After that, I started traveling a bit and lived in Aarhus, Denmark, Charlottesville, Virginia, Singapore, Denmark, Bangkok, Thailand, Ho Chi Minh City, Vietnam, Vejle, Denmark, and Dublin, Ireland. And now I am, as of last week, back in Vejle, which is an awesome place. You should Google image Viola, and you'll see some cool stuff. I went to school at these places. I started at Boston University as an aerospace engineering student, but never really got into any of the aerospace stuff because I only stayed for a year. So mostly I did some physics and engineering type stuff. I transferred to Stony Brook University, where I studied physics and biochemistry, and then eventually I wound up at Hack Reactor. I've worked in these places, and I list these just to give a little credibility to myself, so you trust me when I tell you I know how to do problem solving. When I graduated from school, I wound up working as an accelerator physicist, and I worked at places like Brookhaven National Lab, Stanford Linear Accelerator Center, which is another national lab in the US, and at Stony Brook's University Hospital and Biomedical Engineering Department. I worked on all sorts of hardware engineering problems as a physicist that were related to accelerator devices. So whether we were smashing atoms together or whether we were making medical devices that used radiation in some way or another, that's what I was doing. And when I graduated from college, and after I had worked some of these really, really low paying jobs through the university system, I wound up at a company called Varian Medical Systems, which is where I wound up in, or how I wound up in Silicon Valley. They're in Palo Alto, right down the block from Google and Facebook and all these big companies. And I worked on radiation therapy machines there, which have particle accelerators inside. And that was the first place where I ever applied code in a job where it actually did something that made us money. As I worked at Varian, I met tons of people who worked at these big tech companies. And my company wasn't a tech company. We were a science research company. Varian, they invented the MRI, and they invented night vision goggles, and they invented radar and all of these sorts of things in the past. But they were like a long time old company, way before internet ever came out. They just happened to be in Silicon Valley. They're still innovating and doing great things, but it wasn't a tech company. But I was surrounded by tech employees, and that's where I really caught the itch to get into software. There's a whole bunch of reasons. There was some financial aspect to it. There was also a huge interest in the fact that projects could start and stop in such a short period of time. By stop, I mean become complete. Whereas in my physics career, you would start a project and then 30 years later, it would wrap up around that point. And you would never really get to be there at the beginning or the end. You were kind of just stuck in the middle, and you were a small cog in a very big systematic experiment, which at least in the field, in the part of physics that I was in. And so software, with this really rapid turnaround time on developing projects, and the fact that you could show these projects to normal humans like your parents and say, hey, I did a thing, and they would look at it and say, wow, I understand what you're talking about. And that's cool, and I can touch it and see it and play with it. I don't know, there's something about the fact that I could make new products that people could enjoy that really enticed me. And the lifestyle was part of it as well, of course. So I started searching for boot camps, and I found a whole bunch. I found them all on course reports, as you might have seen. And as I read through the reviews, I got very excited about Hack Reactor and another competing boot camp. Compared the two, interviewed at both, and chose Hack Reactor in the end. And so my story began. That was in December of 2016, I entered. I started doing all the pre-course stuff in the summer of 2016. Peter Muller was there doing the same thing at the same time. If you've met him on the help desk, that's how we met. And after I graduated, I stayed on as the lead. We call them SEERs these days, software engineering residents. So I was the lead SEER in San Francisco. And then I was promoted to a tech mentor position, which is a full-time instructor at the Immersive. So I had several cohorts at the San Francisco campus. At that point, or at the end of that, I was promoted to become a curriculum developer, and I worked on some of the curriculum that you will encounter in the Immersive today, both on the junior and the senior side. After that, I left Hack Reactor temporarily. I opened a contracting business where I started building my own projects for my own customers and clients independently. One of those was App Academy. Another was a company called Segura Solar. Finally, another one was the University of Colorado's Law School, where I worked for a nonprofit called the Governor's Climate and Forest Task Force. Built a whole bunch of web apps and curriculum type things for them. As I was contracting, I also got a job at Facebook, which was super fun and really awesome. And I would love to tell you all about it at the next event that we hold. I believe it's Sunday night, but check the calendar. If I got the calendar right, probably did. And this is my background. So before I was a software engineer, I just have a couple pictures. I'll blast through them really quick. This is the National Lab in New York. This thing is called the Relativistic Heavy Ion Collider. It's a big, giant 2-mile wide ring where we smash protons together with gold nuclei, and it creates this explosion of quark gluon plasma, this very hot, high energy, gaseous, liquidy thing, which is the exact state of matter that the early universe was in when the Big Bang occurred, about 10 to the minus 34 seconds after that moment. So that was a fun thing to do. Lots of code to write there, but spoiler, nobody in physics knows how to write good code, so nobody can read each other's code. So we kind of just write a bunch of garbage code and make a lot of graphs and share the graphs with each other. I thought I could code them. This is what the machine looks like that we were building. I built a tiny little, really, really small piece of this giant 5-story tall looking monster. This is what the data that comes out looks like after you run it through visualization software. Later on, I worked on these machines. This is what we were doing at Varian. That's a radiation therapy machine that blasts radiation toward a tumor in your body, should you have one. That's what the insides look like. That was in a test cell where I was putting some accelerator components together. And then here's some pictures of some of the data that we had worked on while we were imaging parts of the machine. This is the part that creates the radiation called a target. Cool, just the pictures. That's the end of those slides. Kind of unimportant, but just want to let you know who I am, because for many of you, I probably haven't met you on video yet. So here I am, nice to meet y'all. Okay, the final thing I wanted to cover was just a quick, I guess, hello from pre-course. This is our very first time all being together in one place. So I want to give you a little history on what pre-course has been. You may not know, but the pre-course program proper was founded only 6 months ago. The pre-course curriculum has existed since the inception of Hack Reactor back in 2012. And so the 5 main repos that you work through, JavaScript cones, Test Builder, Underbar, Twiddler, and Recursion, we've been running those in some form or another since the very beginning of Hack Reactor, and you are going through the same 5 assignments that every Hack Reactor student has ever gone through in pre-course. However, this is a way better experience than pre-course used to be, even if you may have found it to be a little bumpy this round. And here's why. Up until very recently, pre-course was, hey, you passed your technical admissions assessment. We will send you an email to congratulate you, and there will be a link inside to a GitHub team that you've been invited to. Congratulations, please work through these 5 repos. Submit them all to us when you're done, and sink or swim. If you can do it, great, you can come to Hack Reactor, and if not, well, adios. And that worked at one point. It worked for a really long time, and it did a really good filtering process for Hack Reactor for sure. Excuse me. However, as the company grew and got acquired several times, it became apparent that we were going to have a lot more students that we were servicing in a lot more locations across the country. And each individual campus was managing their own pre-course experience. So you might be working through these repos, and if you had a question, you might send an email to the campus, and a tech mentor may send you an email back with a little help, but that was about it. But they were all kind of doing it differently. And so when our most recent acquisition happened, a company called K12 purchased Galvanize in December, they said, hey, we want to open more campuses, and that's going to mean more students and more pre-courses, so we should standardize this into one thing. Wouldn't that be great? And we thought, yeah, that would be fantastic. Let's have Slack. Let's have help desk. Let's have office hours. Let's give more and more support to our students so that they don't have to struggle through this thing independently, scared, not knowing that others are struggling at the same time. And we thought that having a full pre-course program where everybody could be in one place together and meet before they all go to their separate campuses and are now in separate Slacks would be good for just so many different reasons. And so we started building out pre-course as a program. So I just want to give a big public thank you to everyone who's going through pre-course right now, because we're in a new program, and I want to make sure that I know the help desk wait time can be long on certain nights of the week, and I know that the office hour calendar books up sometimes, and I know that the history in Slack can run out about halfway through the cohort and make it difficult to see what's going on in the past. And these are all little bumps that come along with the new program. But I also want you to know that the actual formal SEI program, the immersive, has been running in its full form for over 8 years and is a well-tuned machine. Upon entering, you will receive a Google Calendar that is like every single block of every moment of your life scheduled for the next 3 months. Your turnaround time on a help desk ticket is going to be about 5 to 10 minutes max. The resolve time will be about 20 minutes. It's going to be a much different experience, and you're going to be, I think, delighted by the level of organization that you encounter after going through pre-course in a really autonomous, self-driven way. So thank you for your patience, and thank you for your commitment and your energy, as I believe we've all been having a pretty good time in pre-course, but it's about to get a lot better. Okay, so that's my whole spiel on pre-course. Let's get into problem solving. Can I get a thumbs up in the chat if we're ready to move on to problem solving? 10 minutes ago, right? Okay, let's make it happen. So just before this meeting, I put together a new slide deck. It just has a bunch of title slides to give me talking points. Okay, so begins our talk on the problem solving process. When you are working through a problem, any problem, whether it be a software problem, specifically an algorithms problem, or whether it be a math problem, a science problem, an art problem, an architecture problem, anytime you're designing a thing that is meant to have some form or function, you are going to have to go through a problem solving process. For some may come from a background where problem solving wasn't the key, most important trait that you had to have to be successful. And so problem solving, though it sounds like a simple thing, can become quite difficult to the noob if they don't have some sort of process to follow. I really often hear students in pre-course say things like, underbar is so hard because the prompt is vague and I don't know how to solve it, or I don't know how to start. And in my head, I think, welcome to software engineering. That's every problem forever, even when you're really good at it. But the more I hear it, the more I realize, well, even if I don't know personally how to solve a problem, I know what to do next or what to do first, because I follow a process every single time. I do the same steps. And many of those steps do not require me to know how to solve the problem. They are just the initial steps that help me get from, I have no idea what I'm doing, to, I have a path forward to try some things. And so that's what I'm going to share with you. You can apply it to code or elsewhere. But the key is that you do the same thing every time, and that it's systematic, and that without fail, you do every one of the steps in the order that they are written in. If you don't, if you deviate from the plan, you might still solve your problem, but you also probably won't, unless the problem is very easy. Also, if you get stuck, if you're kind of just like winging it, there's a lot of things that can go wrong that can make you stuck without really knowing what part of your solution is the part that has you stuck. So we'll cover that in a little bit too. But if you follow the same steps every time, it will be clear when you need help and when you don't. It will be clear what your next action step is, even if you don't know what your next step is in code. So let's take a look at what those steps look like. I also just want to note that this is my process that I do. I learned it through doing a lot of math and physics in the past, and then coming to Hack Reactor and adapting that approach to what they were telling me to do in coding interviews. You will see 80% of this little structure right here at several points in the immersive. I didn't invent anything here, but this is just kind of like my version through my lens. So you may see a different representation of this in the immersive. They are the same process. There might be different words or different names of steps, but largely I have this in the simplest form possible as an introduction. So here's the steps. Step 1, we interpret the prompts that we receive. Step 2, we do a thing called IOCE. Stands for input, output, constraints, and edge cases. We're going to go through each one in depth after this slide. Step 3, we write some tests, which means, let's say we're making a function called, I don't know, group by. We'll write some sample invocations of the group by function as if it's already written, as if it's done. We'll provide it sample inputs and write down what the expected outputs should be. You can do this with a pen and paper. You can do this in an editor. You can do it with a console log. You could do it with Mocha and Chai if you want to. You could even write assert equals if you remember that from prep, but probably shouldn't. But write some tests. Okay, step 4, we create a high-level strategy, or strategies plural. Notice that we only start strategizing halfway through the entire process. For the whole first 3 steps, we do not need to have any solution or strategy in mind. There's an optional part of step 4, depending on the type of problem you're solving. Many problems benefit from a diagram, so it's nice to have a whiteboard handy or a pen and paper. Step 5, we pseudocode out the one of our many high-level strategies that we had brainstormed, the one that seems the most promising or the easiest to implement. And then once we've done that, we have actually solved the problem, even without writing the solution. Because the solution to any algorithm problem is actually just a series of steps. An algorithm is not code, surprise. An algorithm is a recipe. It's a sequence of a series of actions in a very specific order, step by step. And so you don't need code to write an algorithm. Once you have the algorithm written, the solution, then we implement that solution in code. So actually, unless you are brand new to JavaScript, like before prep has even begun, which comes before pre-course, then implementing the solution, if you have done steps 1 through 5, should be extremely easy and fast. The hard part is steps 4 and 5. Okay, I encourage everyone to hit Command-Shift-3 right now. That will take a screenshot and dump it on your desktop. From here forward, I would love to see everyone on this call or watching this call at a later time. I would love to see that you are following this process, not just when you're stuck, for every single problem you do here forward, especially if you're in an interview situation or if you're in a high pressure or time-based situation. This will be extremely helpful. Okay, I'm gonna take a look at the chat real quick. Make sure I'm not missing anything. Cool. All right, let's go through these steps one at a time, and then we'll do some examples, at least one. Okay, step 1, interpret the prompt. What is this problem asking me to do? So you might get a problem that is like 2 or 3 sentences long. This brings me back to once upon a time when I was a little kid. I remember going through elementary school and doing math problems. I really liked math. I was that kid. And I loved doing my multiplication tables and I loved the division problems, but then one day, I think it was 4th or 5th grade, they introduced the word problem. And it was different. There were no numbers really in the word problem, except a couple sparse ones mixed into the giant paragraph. And what we're taught is to do reading comprehension at that point. Given some description of a situation, scenario, whatever, pull out the meaning from that description of what we need to do next. What are we being asked to do? What problem are we addressing? And so this is always the first step of any coding style problem or software problem, whether we're designing a system or an algorithm. What is the problem asking me to do? And it's important that we do not move forward at all, no matter how tempting it is to write that first var x equals. You should never start your solution until you are very sure you know what you are trying to do. Otherwise, you are about to waste a lot of time solving the wrong problem. So don't do that. While we go through these steps, I'm just going to walk through an example as we go. So here's my editor. And inside, I pasted a problem. This is an underscore problem, but it's not from the underbar assignment. It's an extra one that's called grouped by. It might be in the extra credit, I'm not sure. The prompt is here. I like to use this prompt because it's a really good readiness check for students, because the prompt itself, the problem to interpret, is kind of confusing. Make this a little bigger. I'm gonna make it bigger, and I need to move this. Okay. And this. Give me a thumbs up in the chat if this text is big enough. Cool. Okay, so let's interpret the prompt. The prompt says, given an array of objects, which can be object literals or some other data type that is actually an object behind the scenes, like numbers or strings, immediately confusing. Write a function that takes two inputs. The first input, 1, is an array of data, whether they're numbers, strings, arrays, or objects. Or 2, and input 2 is either a property name as a string, or B, a predicate function. So we have 1, an array of data, 2, some predicate, whatever that means. The function should return an object that groups each of the input array's elements by either of two things, either 1, the property as given by the second input string, or 2, the return value of the predicate function invoked on the current array element. Wow, what a mouthful. If you start coding before you understand that entire paragraph, you are very likely to make a whole bunch of progress on the wrong problem. And so it's important that we take the time to interpret. We'll do the interpretation and the problem solving after we go through all 7 steps, or however many steps there were. I think there were 6. But you can see the value right now of understanding what we're being asked. Spoiler, the problems get bigger and harder as we move forward in our programming career. And so interpreting the problem becomes, it will start as okay, let's take 10 minutes to figure out what the paragraph says, but it can become, okay, let's meet with all of our stakeholders and determine what the requirements of this full project are, and then break them down into smaller pieces. Okay, step 2, IOCE, input, output, constraints, and edge cases. Now that we'll assume that we've interpreted our prompt, the next step is to do this. I always just write down input, output, constraints, and edge cases. And then I actually just list them. I make sure that I understand what my prompt is asking me. And it says, it told me that there would be 2 inputs. And so here I will type what the 2 inputs are. It's going to be an array of certain kinds of data types. And then there was also a second thing that was either a string or a function. We'll come back to this when we do the problem. Then I would type in the output. Well, the prompt told me I was expecting an object. And in the object, there were certain keys that are associated with certain values. And we'll address that after as well. Constraints stands for, or means, things that I'm not allowed to do. For example, let's make a really ridiculous example. Let's say I want to design a vehicle, and it's going to have wheels. And there's a constraint to me designing and building my vehicle. Maybe I only have 3 wheels in my inventory of parts. And so I can't make any 4-wheeled vehicles. Can't make a car. That's not going to work. That would be a constraint. In code, A constraint might be something like, well, your algorithm has to run this fast, or it can only consume this much memory, or it can only have, you can't nest any loops inside of other loops, something like that. And as you move into the immersive, you're going to learn about something called time and space complexity. And then the constraints aspect of problem solving is going to kick in a little bit more. For now, we don't have a lot of constraints in our problems. And finally, the E stood for edge cases. You've probably encountered edge cases at this point, but an edge case is something like, hey, our problem says we're supposed to sort the input array. But what happens in the special cases where like the input array was empty, or all of the items in the input array were the same? Or small little kind of edge case could be like, there are certain elements that have the same value. How do we sort those? Other examples of an edge case, the input that I was expecting was not the data type that they said it was going to be. Maybe I'm supposed to receive an array as input, but I actually got an object, or I got a string, or worse, I got undefined or null. There was an edge case in the underscore last problem, a couple, where it was like n was too big. We're supposed to find the last however many elements in the array. If the array has 5 items inside and n was 10, that was an edge case to handle. Another one was n is not provided. How do we know what to do? Those are edge cases. And so when you're doing IOCE, at this point, you want to list out all the edge cases that you'll have to handle. And then when you actually start planning the solution, you'll handle those edge cases first to get them out of the way, and then you'll do the rest of the business logic underneath. Okay, back to our slides. After IOCE, we write some tests. In this prompt, we're given some sample invocations of the function, so we can just use these as our tests. You'll notice all we're doing in the most simple form of testing is take the function you're supposed to write, called group by, which starts up here, and then invoke it and make a note of what you expect the output should be. We could have also used Mocha and Chai and said, it should, given this exact array, or expect group by invoked with these inputs to be this output. And let's test. Or we can just console log and take a look at the results and verify visually that the thing works. It's all testing. So in this case, you'll notice we have 2 sample invocations because there is the situation where the second input could have been either a function or a string. So I have one test for it being a function. I have another test for it being a string. We wrote some tests. That's it, we can move on now. High-level strategies. How can I get from my input to my output? It's at this point that we can safely assume, okay, I've interpreted the prompt, I know what I'm trying to accomplish, and I have some sort of way to verify if I've hit my target once I write the function, I wrote my tests. So it's at this point in any interview where you really start getting extra verbal and you start thinking out loud and just kind of no constraints brainstorming. So at this point, I might say like, okay, well, I'm supposed to group the items in my collection by some either property or the result of invoking some function. So just like high level Mr. Interviewer or self or rubber ducky on my desk, what would I do here? I'd probably have to like define the empty object. That's definitely gonna happen. And then I'm gonna have to iterate through the collection. And as I iterate through the collection, I'm either going to have to look up the property that was given to me as a string, or I'm going to have to invoke the function that was provided, the predicate function with the current item inside. I'm not really sure how I would do that yet, but in code, but I do know for every item in the array, I'm going to have to find out what group it belongs to if we're grouping them by something. So I'll do that. And then in the end, well, when I determine what group each item belongs to, I'll add them to the object. And then once we're done iterating, at that point, I can return the object. And so that's an example of a high level strategy. I didn't write anything down. I kind of just spoke it out loud. It was like 2 to 4 sentences. It wasn't perfect, but it got me to some sort of idea as to what direction to go in. You should never stop at the first strategy. You should think of it, maybe jot down the bullets so you don't forget, and then try coming up with a second strategy. This problem, there's not a lot of different approaches to it. I could write the solution in like 3 or 4 different ways, but high level, we're kind of doing the same thing. But these problems are going to become a little more complicated soon. Like when you did unique, that one has a lot of different ways to solve it. High level strategies could go like, well, first I'm going to have to declare a result array, and I might even need like a temporary array to store the transformed values in the case where I get an iterator. Okay, so I've got those 2 arrays, and then I'm gonna have to iterate through the collection, and I'm gonna have to check if I've seen this item before or not. If I haven't, I'll add it to my result. If I have, I guess I'll just ditch that item and move on, and then I'll return the result. Or another strategy I might employ might be, why don't I just take every item and run it through the iterator and add it to a set data structure. In JavaScript, there's this thing called a set. You can just write new set and it makes one. A set is a data structure. It's a lot like an object, but every item inside has to be unique. Otherwise, the set will reject the item you try to put in. And so another strategy might be to iterate through the collection and add each item in the collection to a set data structure, and then convert that set back into an array and return that. And so now I have 2 strategies. And I can stop for a moment and think about both and weigh the trade-offs. And you'll find that writing software and writing algorithms is all about trade-offs. There's 1,000 ways to do the thing, but which way is the best or the most convenient or the most affordable in terms of memory? It's at this point that you weigh them. And you should always pick the one first that seems the easiest to get to what we call the naive solution, the easy solution, even if it's not the most efficient. Pick the one that will get you started working toward a working functional product. Then when you're done making that one, if you think it's not good enough, you can go implement strategy number 2 that you've already thought of, and then compare the results. But always start with the easy one first and then iterate forward from there. Okay, so this step, we have our high level strategies brainstormed. They might not work, but they exist. Here's that optional step. It might make sense to make a diagram. For example, if you're in the recursion repos right now and you're working on get elements by class name, and you look in the test code and realize, wow, it looks like they're like iterating through an array of strings where each string represents an HTML tag, and they're building some actual HTML document dynamically in the tests. This is going to be hard to visualize in my head if I don't write it down. So you might want to draw out, here's the body tag, and inside of that, here's the first div that they're adding, and inside of that, here's the next div, and you can draw that picture so that as you come up with the strategy, you can traverse or iterate through the structure that you drew and see how your actual high-level strategy is going to play out as you draw it on your whiteboard or in your notebook. All sorts of reasons to make a diagram or to draw some things out while you strategize. You should definitely verify that your strategy is promising before moving on to the next step, and a diagram is a really good way to do that. Final 2 steps. Now that we have a strategy, we've kind of proven to ourselves that we believe in it. It's time to actually write it step by step in pseudocode. Pseudocode means that you are going to write one comment in plain text, plain English, no code characters, no for, var, let, equals, whatever. There's no if this, else that. There's no equal signs. This is not code, this is English, as if you're telling your mom how to do it. This might look like this. We typically write our pseudocode inside the shell of the function that we're going to implement. And for group by, it might look like declare a result object. Iterate through the collection for each item. And if we're going to go inside what is meant to be a loop, we indent just like we would in code. You might say for each item, do thing 1, do thing 2, and then we intend for the loop to end. So we unindent. And then maybe we return the result object. This is a very simplified, this is not the right pseudocode, but this is just to make an example. The indentation thing applies for if and else statements as well. Anything that's a block that the code inside gets indented, we would indent that pseudocode too. And we're really gonna just like really granularly, step-by-step plan the code we're gonna write. This is important for the following reason. There's two things that can trip you up while you're writing code and trying to solve a problem. Either the strategy is wrong or the code, the implementation is wrong. Strategy and implementation should be separate because they're both hard and they're both confusing. So if you take both of them and you combine them, you make a super confusing thing. And this problem was hard enough to begin with, so don't overcomplicate it. If you jump straight into code with no strategy and no pseudocode, what you are doing is both strategizing and writing code at the same time. And so when you get to the part that you do wrong and you leave either broken code or broken strategy behind you, and you keep going because you don't realize it, and you just keep coding and coding and coding, and then that like moment of faith comes where you hover over the run button and hit click, and then close your eyes and pray, and then you kind of just like peek. Did it work? If it didn't in that moment, it's really hard to tell why. Well, did I make the wrong steps happen in the wrong order, or do I have a syntax bug? I don't know. Did I use the wrong method, or did I use the wrong strategy? And if you have to figure that out now that you have a whole bunch of code, you're going to be, one, really unwilling to delete all that code and start over. So you wind up in this place where you're like committed to the broken strategy or broken solution, and you spend hours trying to make that one work because you're afraid to start over from the beginning because it was so painful to get to this point already. There's an emotional attachment to your original solution. Or you misinterpret what the bug is, or the bug is just harder to solve in your debugging process. So I think it's best to isolate the two things entirely. Write the strategy, verify that this is going to wind up working, and then and only then write out the code. So once you've got the pseudocode written, you now have a working strategy. Well, a believed to be working strategy. And now finally, you can come into your code and go on to the final step, which is implement the solution. I think of this as just, I heard this in a talk recently. I don't want to claim ownership of it, but they said that writing code is just translating instructions into a language that a computer can understand. You're just writing instructions for a computer to do. And so you think in English, but the computer thinks in code. So you have to translate your thoughts into the language that it knows, which for us is JavaScript. So at this point, the coding is easy and fast. Declare a result object. Whoops, sorry. Var results equals objects. That was easy. Iterate through the collection. Okay. Okay, I have a loop and it iterates through the collection. Then maybe I'll take the pseudocode and put it inside. And then I start typing out the code for those steps. If you get stuck implementing this tiny little step, you don't know how to do it. Well, guess what? You just took your big problem and broke it down into a set of really small little problems. This problem, which might say like, make a copy of the array, but only the first 3 items. That problem's a lot easier to solve than the total problem. And it's also a lot easier to look up. And so now all you have to do is look up a method that can make a copy of your array or a slice of the array, rather than having to go Google, how do I group elements in an array by their predicate result? Like, that's a lot harder to look up. So you should be trying to take your big problem and break it down into the smallest, little, most granular task possible. That way, when you have to do your research, it's a lot easier. And then we just fill our code in. And when we're done, we already have tests with sample inputs and outputs written. We can run our code and see if it passes or not. And if not, that's the moment where you change from problem solving to debugging. And this is about problem solving. So that's what we're going to cover today. Debugging is an entirely different topic, though it's very related. And it becomes a matter of how well you can interpret your error message and investigate and sniff through your code to see what the stinky part is. Okay, I'm going to pause at this moment. That's the end of the slides. I just put this at the end so that we could talk about it afterwards. At this point, I want to just pause for questions before we go ahead and solve the problem, and see if anybody has any thoughts that they'd like to share or ask. Please do so verbally too, and don't use the chat, because we're going to have viewers watching this who couldn't attend today. So I'd like them to be able to hear the questions.
Do you have a method for knowing if your strategy is right, or feeling confident that your strategy is right before you start? Or is it kind of just a feeling based on past experience?
Great question. No, I do have a process to check my strategy out, and that's the diagram process. So let's do a little quick example. There's a whiteboard in Zoom I can use. Somebody just say yes if you can see the whiteboard.
Yes.
Yeah.
Thank you. Is it the only thing you can see?
Yes.
Excellent.
On my computer, yes.
Yeah. Good. John liked that one. Cool. So let's say that our job is to sort the array. Let's have an array. I'm using a mouse right now, so bear with me. Wait, 1, that's okay, we'll keep 1. We'll put 10, and then we'll put 5, and then we'll put 12, -1, and 3. Okay, so when I'm checking my strategy out, I always start with the sample input. I'll just call it in. And then I know what my output should be. I'm not going to draw it because I'm just going to try to answer this question quickly. But imagine we also wrote out the output. Then I have my pseudocode steps. So I'm going to follow the steps top to bottom as if I'm the interpreter. I don't need code to check the steps. I just need the steps themselves. So imagine that your pseudocode said, okay, we're going to iterate through the array from left to right. And we're going to, and so that means that like we have an index, right? And that means we're going to have an index variable. So I'd like to actually write down I. It's going to start at 0. Okay. And I guess my pseudocode step might say compare the current element to its neighbor to the right. And if the neighbor to the right is smaller, then you should swap them. And then just do that as you iterate across the array. And then when you're done, return the final result. That's a broken strategy, by the way. That won't solve, it will sort some arrays, but not all. So now that I have the strategy, I'm just going to actually do it on paper. I'm going to say, okay, well, current item is 1. Is the neighbor to the right bigger than 1? Sorry, is it smaller? No, it's not smaller. So I don't have to swap anything. Okay. Now I becomes 1. And my little pointer is looking at the 10. Is the neighbor to the right of 10 smaller than 10? It is. Well, we should swap it. So we're going to swap these two. And that means that we wind up with something that, sorry, the eraser's not working. But we're going to wind up with something like this, 5, 10. Okay, next iteration. I becomes 2. Now we're here. Is 12 smaller than 10? No, it's not. Okay, I becomes 3. And I'm just gonna like step through my strategy steps and actually draw it out and see what happens. And if I can get from a sample input to a sample output on paper in my drawing, then I know that these English steps lead to a solution. I try to think of every algorithm problem I do, or really any code problem, as if everything we're doing actually relates to like the physical world that we live in. And if you think about it, when we invented computers and we wrote these programming languages, we didn't invent it for the computer. We invented it for ourselves, for the humans to understand. And so if you look at the words that we use when we're talking about code, they all map to our everyday life. An array is a collection or a list. An object just means objects, like an object on the table. I have a pen object and I have a mouse object. A mouse has properties. It is round. It is short. It's loud. It makes a clicky sound. It's black and gray. And so this object has keys and values. It has keys like color and height and shape. And then the values are round and gray and black and short, whatever I made the properties. And all of code is kind of like that. So when I'm doing an algorithm problem, I try to think of it like if I'm trying to sort numbers in an array, I might think of it as if I have index cards on my table with numbers on them. And I have to think about like, how would I rearrange the cards, and step by step, in what order would I do it? And I don't even just mean rearranging them. I mean, what would I, the person, do? I would look at the first card. And I'm going to look at all of them. So I look at the first card, and then I'm going to look at the second card. And then I'm going to compare these two. And if the one on the right is smaller than the one on the left, I'll switch their order. And I'm visualizing that in my head, and I'm drawing this on paper as I go, not thinking about code. It doesn't matter that it's an array. It only matters that there's numbers in an order that I need to rearrange, objects, things. And so that's the way that you can verify your strategy. When you're doing something like get elements by class name, that's even more applicable for a diagram. That was a bad thing to do. Let's just leave an undo button. Oh, that's a lot of clicks. So get elements by class name, you might have like a body tag with some divs nested inside. So you can draw out the actual DOM and say like, okay, I have a body tag, B, and then it has 3 children divs, B, D, D. You might draw them like HTML elements, but I'm on a mouse in a live code share with a lot of people, so I'm not gonna do that all over the place. And then you connect them with the line, because this diagram represents a body tag. Let's use some text. A body tag with a div, and then another div, and then another div, and then the closing body tag. And maybe you had a couple more elements. So like maybe this div had a paragraph inside, and this one had like 2 other tags, 2 other paragraphs. And your goal might be to go through every single item in the tree or in the DOM and check if it has a class. And so the diagram might become very helpful as you think about what your code would do. Like obviously you can't iterate from left to right in a thing that doesn't have a left and a right. So you might have to start thinking like, well, what are the ways that I could approach every element in the collection? Like, this looks like a good place to start at the top. It looks like the beginning, but after that, like, am I gonna go here and then here and then here? Or should I start up here at the body and then go to this div and then go down to its first child? And then when there's no children left, should I go up into the next child? Should I go in this backwards order that I just did, or should I start on the left side? And just having the picture and then taking a walk through the steps that you wrote down will pretty quickly verify whether this is going to turn out successfully or not. So that's my answer to that. Does that satisfy the question?
Yeah, for sure. Thank you.
Yeah, no problem. Thanks for asking. Anybody else?
Maybe like coming across, like, rather than problems we might not understand, like interacting with libraries. Like, it's the first time I'd used underscore or things like that. Like, if we're like learning a new library or API or something, do you have like any suggestions on, I don't know, like learning about them or something?
Sure. I have two thoughts immediately in my head. Thought one is always use the official documentation for that tool. And there's almost always, without fail, a getting started page. And always look for that. If it's not on the front page, search getting started, or even just Google getting started jQuery docs or something like that. Sometimes the word core means like the main part, and you might want to start there. And you could pretty safely skip the installation instructions until you're actually going to wind up using it. So start reading there. There's a person who thought about you looking at this tool for the first time and very intentionally wrote some information down. Whether or not they did it in a way that is pleasing to look at, it's an entirely different story. But they did think of you, and so look for where they put those thoughts. And then the second thing is just tinker with it, play with it. Follow the install setup, whatever it is, install the thing into a place where you can actually use the new tool, whether it's a library or a place to send in an API call to. And be willing to just play with it and break it and look at why it doesn't work, and then play around some more until you get some results that are interesting to look at. I find that a lot of new programmers or software engineers, especially people in your position, can be afraid to do the wrong thing. And I want to say I understand it, but I think I'm so far removed at this point, being 4 years down the road, that I've forgotten how scary it could be to be wrong. Because today I'm wrong all the time, and I'm so used to it. That I've learned that I'm expected to just break things until they actually aren't broken anymore. Until you've it's almost like Edison said when he was trying to invent the light bulb. I haven't failed yet. I've just tried 10,000 things that didn't work. And so I'm 10,000 attempts closer to something that does work. It's the difference between science and engineering. We can fail forward in engineering. And with code, it's like so much safer because nothing will physically break because none of it's physically real. So write 10,000 broken API calls until you get it right and get your data back, and then you know how to do it. It's pretty safe. Next question.
Hey, I have a question. Can you hear me?
Yes.
How do you stop tunnel visioning on a strategy that you have attachment to? Like, for example, you might have spent 30 minutes trying to work it out, and maybe you drew out all the diagrams and everything, and it just doesn't work. And then when you do try to deviate from it, you just end up like creating more permutations of the same strategy. Does that ever happen to you?
Oh yeah, all the time. Creating different permutations of the same strategy might be a good way to go. Maybe you weren't totally off. Maybe there's just like some sub problem in your solution that was the broken part. So like one thing is to realize like I might not need to deviate entirely from this plan. However, you should, at this moment, if you're stuck, probably deviate from the plan. And so that means just comment it out, put it to the side. You don't delete it and just ditch it forever. And that kind of helps, for me at least, like commenting it out, putting it at the bottom of the file where I'm not staring at it right now, so it won't distract me, but where I know it's safe, I'm not going to lose my work, makes me feel a lot more willing to go think about some other strategy.
Oh, yeah, that's a good
Often,
idea.
yeah, often when we're stuck, you get to a point where like you stared at the thing for so long that even if there was just a comma in the wrong place, you're probably not going to see it. And you're probably frustrated and angry at some point. And it's just not constructive to getting into a creative mindset. So what I do in that situation is I just take a break, 10 minutes, go outside, take a walk, separate myself from what I'm staring at, just to context switch once, so I can context switch back in to this problem solving experience. But if you're not frustrated and you're just blocked, then you don't need the walk. You just need to switch your attention to a different strategy entirely. And I think it's just a coding like maturity thing where eventually you realize it's okay to have parallel thoughts and to have two strategies at once. In fact, it's better to have more than one so that you can write both and then compare them for efficiency's sake later. So ditching your current solution doesn't mean ditching it forever. It just means for a little bit until you decide to go back.
Thank you.
One thing I heard was love the problem, not the solution. Like we're focused on solving the problem, and if we get sidetracked into our solution as the way, that can be a really like a narrowing approach. But we want to love solving the problem in different ways. That's what we want to keep coming back to.
I love that, Peter. Okay, I'll take one more question if there are any.
I have a question.
Okay.
How would you go about solving a problem that you're completely stuck on when you have a time constraint on that problem?
Good question.
Help desk. I know that that's there, but like you as in like you don't have any help. How would you go about that?
I would do it the same way that I would solve any other problem. The ticking clock thing is stressful for many. For me in particular, I hated that in school, having the time limit on a test where I knew there wasn't enough time to solve all the problems. But the moment that you let that kind of like distract you and capture your attention, it's the moment that you start to lose. And so you kind of have to be okay with failing, and you have to learn to accept that you could not solve this in time. And that anxiety has to kind of be like pushed to the side so that you can just focus on the very regimented and methodical, systematic process that you've been practicing all of this time before. And if you haven't been practicing that process yet, like today's the day to start. I'm describing it for you now. But for me, like when I'm in a time crunch, I don't care anymore because I'm gonna do the same steps no matter what, whether I have the time crunch or not. I'm gonna interpret the problem, I'm gonna do IOCE, I'm going to write a couple tests, I'm going to make a high-level strategy, write some pseudocode out, and then I'm gonna try to implement the pseudocode. And if that doesn't work, I'm gonna write different pseudocode for a different strategy, I'm gonna try that. I'm just gonna keep doing that relentlessly until the problem is solved. And if I don't solve it in time, then I guess, oh well, then I didn't, and it's okay. My life will continue, and I'll still be a software engineer tomorrow. So that's all.
Makes sense.
Yeah. I wish there was a better answer that was like, oh, just do these 3 things and the problem will be solved. But you can't shortcut the shortcut. You got a problem-solving process. You got to just stick to it and be creative.
Thank you.
No problem. Becoming a very good debugger, which is a different skill, will also help you in that situation. If when you get stuck, you start flailing and just doing the trial and error, guess and check thing, like that normally doesn't work out. So refining your debugging process is something that you should practice if you're finding that you often get halfway and get stuck in the middle and can't get from the middle to the end. That'll come in real handy when there's a time crunch.
Okay.
Another talk for another day. All right. Does anybody want to take some time to solve group by with me? Give me thumbs in the chat if that's interesting. Otherwise, we can do something else. One person just wrote like 30 Bs. All right, let's solve some group by. Why is my mouse not working? Here we go. Share the screen. Okay. Let's, in a more detailed way, interpret the prompt. This prompt tells me I will be given an array of objects. And then in parentheses, it tells me, like it quotes these objects. So it's like they're objects. They're not curly brackets, objects. An array of objects. So what are the objects? In parens, it says they can be object literals, which means they could be the curly bracket object type of thing, or they could be some other data type. In JavaScript, everything is an object, actually. Like your arrays, those are objects. Strings, I think those are objects too in some way or another. They have a dot length, so they have properties you could look up. Numbers, booleans, whatever. It's just we're given an array of things of assorted data types. And our goal is to write a function that takes these two inputs. So, okay, as I'm interpreting, I might start doing my IOCE, because this is a good moment to write these things down. So I'm given one array of data, I'm just going to say, because I don't know really, I'll put it in quotes, objects. Could be string, number, boolean, object, whatever. Okay. But our function takes two inputs. It takes that array of data, and the second input is either a property name as a string or a function that we're calling predicate. And then I look down at the function signature and it says predicate here. So I can say array of data and two predicate. Let's maybe make this 2 lines. Either string or function. So I've both noted what the input was, it's an array of data, and then I wrote down what the data type was. Both of those pieces of information are pretty important to understanding what the input is. Okay, so I got my inputs. The function should return an object. So my output is an object that groups each of the input array's elements by something. So let's see, object with groups. I can start there. Okay, so we're grouping elements by either their property as given by the second input string. Okay, so remember we had an array of object-like things. So if we get a string that represents the name of a property, that means we can look up that property in the current object. So like, here's an example, the second example. We were given length, the string, which is the word length. That means like for each of these objects in the data array, we want to know what their length is, their length property. And so when we look at the final result, we see an object down here. And the name of the keys are lengths, they're numbers. And if you look at the values, we have an array that has strings of that particular length inside. So the 5 array has apple inside. There's 5 letters in apple. The 3 array has cat because there's 3 letters in cat. And then the 4 group has boat, card, and bond inside. 4-letter words. And so we can intuit that length means like literally card.length or card square brackets length. We're looking up the length of that string. So if we get, where were we? If we get a string as our second input, then we're going to group the objects by their property. However, if predicate was a function, in that case, we should group the items by the return value of the predicate function. It's kind of like, I guess you could call it the iterator function if you're thinking about underbar also, even though predicate's a little more accurate, I think. So the return value of the predicate function invoked on the current array elements, meaning take predicate and invoke it with the current item as input. Whatever you get back when you do that, predicate of item, that's going to be the name of the group that this current item belongs to. So if we look at the sample code, here's an example of what a predicate function could be. The predicate function could be any function, but in this test example, we'll make it this function. And it's called first letter. It takes a word as input. And then it returns the character at the 0th index of the word. So if we look down at the example, the first word is apple. If we put apple as input to the first letter function, we would return the first character of the word apple, which is A. So apple goes in the A group. The group was defined by the result of calling the predicate function with the current item as input. Apple goes where word goes. The return value was A, so that's the group it goes in. Okay, so for output, we have an object with groups defined by either, defined by the predicate's results. I think we could just leave it like that. If I do this well enough, I don't ever have to go back up and look at the prompt ever again. So it's good to kind of break it down. Okay, and finally, that was it. That was the end of the prompt. The prompt ended here. So I think I've interpreted it. Let's wrap up our IOCE second step. We have our input, we have our output. Do we have any constraints? If I'm in an interview situation, I'm gonna directly ask my interviewer, do I have any constraints? And then they're either gonna say nope, or they're gonna say, not to start, but if you solve it too quick, I'll give you some. Or they'll say, yeah, no loops nested in other loops, or you can only use one array. You can't make more than one, or something like that. But for now, this problem has none. And then edge cases, the only edge cases I can think of is if the collection wasn't defined, or if the predicate wasn't defined, or if the predicate wasn't a function or a string, or something like that. But I'm gonna ask Peter, hey Peter, Mr. Interviewer, do I have to worry about either of the inputs not being the data type that they are, that we are expecting them to be?
Not for this round.
Okay,
This round,
all right.
you can expect both of the inputs that we've described in the prompt up above, exactly.
Perfect, thank you so much. And they'll always be provided, right?
Correct.
Okay, cool. So I'll move forward with that assumption. And then boom, there are no edge cases. Okay, high level strategy. Let's talk about it. So, hey, Mr. Interviewer, hey, Peter. I see what we're gonna have to do here is we have this list of items or this collection of items, and we need to, if we're gonna group them, it means we have to look at every single item in our collection and determine what group it belongs to. And when we do that, let's say we looked at the first item and we determined, I know what group you belong in. I have to know, like, is there a group that exists somewhere that I can put this item in, or do we have to create that group first and then put the item in the group? Like that, I can see that being one of the steps that we have to do. Like we need some container and it's going to have groups inside of it, separate locations to put our items. And they can't all exist in advance because the collection, nobody knows what the collection is before we start running the function. So, how are we going to have a container that's an object, because the prompt says our output's got to be an object? How are we going to have an object with keys that are the names of our groups? If we don't, I can't just hard code like group A, group B, group C. I gotta, like, as I go, determine the groups and add them, but only add them when they're new. Otherwise we'll overwrite things. Ugh, that's kind of complicated. I'm thinking, I'm talking, I'm doing, okay. I'm stuck, okay. Wait, got it. We're gonna need to declare an object, an empty one. And then we're gonna have to step through the collection one step at a time. We'll iterate through the collection. And for each item in the collection, I'm gonna have to look at the result object, and I'm gonna have to ask a question. I'm gonna have to say, if I look up the predicate or determine the predicate for this item, does that result already exist in the object? If it does, I'll add the current item to the group. If it doesn't, I'll create the group and add the item. And then I'll do it for the next item, and for the next one, and the next one, and the next one, until I've reached the end. And then I'll be done, and I can return the final output. And then my interviewer might say back to me, well, I think you're missing a part. Sounds like a good plan, kinda, but like, have you thought about how you'll determine the groups in a little more detail? And I'll go, oh yeah, the predicate, that thing, it could be either a string or a function. So like, I can't write one line of code that does two different things. Well, I could, but I probably won't. So that's another step. So now I gotta change my plan. I guess the plan now is declare the empty object, figure out if the predicate is a string or a function, and then iterate through the collection. And then based on whether the predicate was a string or a function, look up the group name in the appropriate way, because it's going to be different syntax if the predicate is a string or a function. But I think high level, I got a strategy now. Peter, what do you think? Do you think like I'm on the right track, I'm going in the right direction, or am I about to waste our time?
Right. It sounds like you picked up on the fact that the way we're going to decide whether or not we already have an existing group for the current element that we're looking at is going to have to be based on what data type the predicate is. So our original strategy seemed to be a bit vague in that situation, but we were able to determine that the thing one and thing two are going to have to focus on what type of predicate we're given. And if we can break that down into whether it's a string or a function, that'll help us decide how to group.
Okay, cool.
And I just got a call over the wire. It would actually be nice if we also get no input at all for the collection. Not no input, but if we got a collection that was empty. We also might want to consider that.
Okay, so now we have an edge case. Empty collection. All right, throw a little curveball at me. This must be one of those Google interviews. All right, so let's think about it. So what do we want to do if the collection is empty, Peter? Do we want to just return, like, we have options. We could just return an object that's empty, because technically that would still be a grouped object. It's a group of nothing, and so there are no groups inside. Or we could return like a message like error, or we could return a message like a string that just says, hey, there was nothing in the collection. What do you want me to do?
Let's go ahead and return a string describing that there's nothing in the collection. That way we can pass it off to the QA team.
Okay, cool. So edge case 1 is an empty collection, and we will return a string with a helpful error message. All right. Safe to move forward. Is there any other edge cases you want me to consider?
There are no other edge cases to consider.
Sweet. Okay. So if that's the case, then I think we can write pseudocode now. My first step, I'm always going to handle my edge cases first. And so I'm going to check, I'm just going to ask the question, if the collection is an empty array. Actually, I'm just going to say if the collection is empty. Sorry, spell check or whatever. In that case, I will return the message, uh-oh, there are no items in the collection. Sad face. Okay. And then I can go on to the main part of the function. So the first step of the main part will be to declare a result object. And then I said I was going to determine, let's think. I wanted to determine if, I don't even need the word determine, just say if predicate, if the predicate is a string, then I'm going to do one thing. This is the other case where the predicate could be a function. So I'll say also there's if the predicate is a function. Two separate parts. Okay. We'll do probably the same thing, whether it's a string or a function. There's just going to be one part that's wrong. I'm sorry, that's different. And then in the end, I'm going to wind up returning the results object. Okay, so I have like my outermost steps. Let's talk about what happens if the predicate is a string or if it's a function. Well, let's just start with the string case because I think they're going to be quite similar. I'm going to say if it's a string, we should determine the group that the current item belongs to. And then I'm going to ask a question. I'm going to say if the group exists in the results object already, add the current item to the group. And then I'll say if the group does not exist in the results object already, create the group, or I'll say add the group to the results object, and then add the current item to the new group. I did that pretty fast, so let's just step through it real quick. If the predicate is a string, I said determine the group that the current item belongs to, but that's kind of vague. I don't think I could translate that English sentence into code easily. So I need to be more specific. I should say, look up the property called predicate in the current object. And I'll just say item. That's more specific. In objects, we look up their properties by using dot or bracket notation. So this translates into basically like results dot or square brackets predicate. So more specific, later on, I won't have to think about it. I'll just read the line and then write the code. So if it's a string, we're going to look up the property in the object. And then I'll say determine group colon, do that thing. So this way the word group still makes sense. If the group exists in the results object already, add the current item to the group. If it does not exist in the results object already, add the group to the results object, and then add the current item to that new group. That seems to me like a process that's going to work. I'm going to run with it. And then I'm going to copy this whole thing because I think these are like the same steps except for one. I think if I follow these same steps, except this one, they're going to be the same. Determine the group is the unique part. So we have to determine the group in a different way. For the function case, we'll invoke predicate function with current item as input. And that's where it's different. So now that I've got these two sub-problems solved, I'm looking at it and I think it's going to work. This would be a really good time to not write code yet and to get out your whiteboard or your notebook and actually step through one of your sample inputs and say like, okay, the first item, I have an object. The first item is apple, and the predicate is a function. So we declare our empty result object. The predicate is a function, so we wind up here, determine the group. So invoke first letter function with the current item as input. Well, that would give me with apple A. So now I know the group is A. If the group exists in the results object already, I'll look at my drawing of my object. I'll notice there are no key value pairs inside, and then I'll, with my whiteboard marker, draw in the group A and give it a bucket or an array and put the word apple inside. And then I'll go, okay, done. What was the next item? Cat. Is there a C in my group object already? No, there's not. Okay, make a group called C. That's this step. And then add the current item, cat, into that array. And I'm just gonna step-by-step draw that out. I'll abstract that out for the demo. I'm going, unless anybody wants to voice right now that they really need to see me draw that. Does anybody want to see that?
Not with your mouse.
Exactly. Yeah. In real life, I would do this on a whiteboard. If I was Steve, I would do this right here. But I'm not. I'm me. I just got to Denmark, so I don't have a whiteboard. I'm sorry. I'll have it soon. Okay. So imagine I drew all those things, and then I would say, yep, it looks like I did wind up with an object that looked like this in my drawing. So now I can write the code. And watch how fast it will happen now that we took the time in advance to define our strategy, verify that it works, and be very intentional with our pseudocode to make sure that like each one of those sentences really does translate into actual code. Ready? If the collection is empty, if collection dot length equals 0, return the message, uh-oh, blah, 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 blah. So I take the message, return this, and use single quotes because we are JavaScript developers. And that's what you do. Okay. Okay, next step, declare a result object. I'd like to change the name to groups, if everyone's okay with that, but var groups equals object. Done. Next step. If the predicate is a string, if predicate, oops, if type of predicate equals string. And all of this was indented, so it goes inside. Determine the group. Look up the property predicate in the current item. Uh-oh. I'm coding and I realize that I made a mistake. So I should pause and I should go back and fix my pseudocode, not just code the new thing. Did he do it on purpose? Who knows? No, I didn't. I just messed up. So we forgot to say right here. Well, actually, we have a choice to make. Do we iterate or do we check the predicate? We could worry about the efficiency of it afterwards when we refactor. But for now, I'll say inside the if. Iterate. I'll just say it like this. I'll say for each item in the collection. And then I'll just take everything and indent it to the right. That should do it. So I'll copy that. Cool, both now work. So it was okay that I did that I wrote pseudocode, I believed it worked, I went into my implementation, and then in the process realized, uh-oh, I made a mistake. You just go back and fix it. You go to the previous step, fix that, and then come back to your current process, which is solution. Okay, and now I'm gonna say collection dot for each. I'm gonna use the native JavaScript one just to like demo it. This is how you do it. That's a for each loop built into JavaScript. You don't need underscore for this. Only works on arrays though. It's the same as the underscore each, except instead of the first input being collection here, it's a method of the array. Otherwise, it's literally the same exact thing. Okay, so collection dot for each, it reads like this: for each item in the array called collection. Okay, determine the group. Var group equals item of predicate. We know bracket notation. We know that our predicate is a string. So if that string was the word length and item was a string, this should work. Okay. If the group exists in the results object already. If the object called groups has its own property called group, that just says look in the groups object and check if there is a key called group. That's the best way to do that. So if that is true, add the current item to the group. Okay, groups of group dot push item. We know that the groups, like here's the A group, we know it's going to be an array if it already exists. So it's okay to dot push something into the array. Groups of group dot push item. Same thing as like saying groups of A dot push apple. Or actually I could just say, remember, one line of pseudocode for every line of real code. Else, I think I messed up my indentation. Else, add the group to the results object. Groups of group is an empty array. And then add the current item. Groups of group dot push item. Let's check our brackets. Yep, looks good to me. That kills the for loop. This kills the if statement. Then we have our function version if it was a function. And then finally, we would just return the results object, which was called groups. Now I know that if this works, this is going to work because they're identical. My code is not going to be very dry. Dry stands for do not repeat yourself, or don't repeat yourself, as opposed to being wet, write everything twice, waste everyone's time. I'm a little wet right now in this code, but that's okay. So now that I've gotten this far, before I spend more time building out an identical, just slightly different case, I think it's fair to walk through, give it a read, and then test it. Meaning like it's safe to run my function as long as I don't do the function case and I only do the string case. If group by could only take a string for the predicate, then this function, I believe, would be complete. And so who agrees that this is a good time to actually run my function? at least one person has to say the word
I
yes.
think it's pretty good.
I think someone thinks it's pretty good. Pretty good. Okay. I'm just messing with you.
What
Sure,
does the
the code-
interviewer say?
What did Peter? What do you say?
I think because we have a similar algorithm for both different classes of predicate, it would be good to test our strategy here. This is a small part of the problem, but it's a large part of our strategy. So I think it makes sense to go ahead and give this a test.
All right, cool. Let's make it happen. Now, Peter, I do believe that this code could be better, more concise, maybe more readable, maybe less wet. But my goal is to come to the naive solution first and get results, and then refactor my code to be a better code quality. So I think it's going to work. So if I'm writing a JavaScript file, just in a normal, this isn't even a repo, it's just a folder with a file inside. If I save my code, it's called groupby.js. And because I have Node installed, I can run my JavaScript file and the output will come in my terminal. So maybe you haven't done this at this point. I'm just going to make sure that I take my function call and wrap it in a console log so that it logs it. I can actually just come over here and type, notice I'm in that directory. I'm just going to type node and the name of the file, and it should run my code. And boom, look what I got. I have an object with 3 groups, 3, 4, and 5. All the 3-letter things are in the 3 group, all the 4-letter things are in the 4 group, and all the 5-letter things are in the 5 group. So hey, Mr. Interviewer, do you believe that this was the result we were looking for?
Let's compare it. And it looks like,
The keys are in the wrong order,
right.
but the groups look the same, right?
The groups look the same, and we didn't mention that key order was one of our constraints.
And actually, I believe from my studies that keys in an object aren't really guaranteed in the pre-ES6 world, at least. And it's really common for keys in an object to not be in the same order in one environment than in another. Do you think that's right?
Correct. Pre-ES6 among different browsers, even sometimes objects keys will be in different order. What we care about is the existence of the key value pairs, not necessarily the order.
So then I'm right.
Yes.
Yeah, I am. Cool. Sorry, I had to. So it works, and that means that I can map my code from the string case to the function case. And so let's just take everything that isn't the unique step, or let's take the unique step and save it down here. We can get rid of all of this and just take all of this. We can change the word string to function. And then grab our function pseudocode line and replace the string pseudocode line. And then we can fix this line of code. So now we're determining group. We're going to do it by invoking the predicate function with the current item as input. So that's as simple as saying predicate of item, and that should give us the group. Because it's the same, if predicate was, in this example, first letter, and my item was apple, I would just say first letter, let's say first letter of apple. And that would tell me, hey, that would be my group. I hope that makes sense. So I think it should just work now because it's the same process. We said that already. So let's try it out. We will uncomment the function case, wrap it in a console.log, and save. And let's see what we get. Node groupby.js. Looks pretty good to me. All the A words are in the A group. All the C words are in the C group. All the B words are in the B group. Hey, Peter, what do you think? Did I do the thing?
I think you did the thing, and I think you're right, which seems to be the goal of this interview.
The goal is the job, but I think the job comes when I'm right. Or when you like me. And being right might make you not like me if I am really obnoxious about how right I am. And so I take it back. I hope that we are right, though, as we have
Yes.
solved this problem together.
Yes.
What if the input was empty? Would we still be right? Save. Run it. Uh-oh, there are no items in the collection. Sad face. Okay, so I've proven that in all cases, our code functions as expected. Is the better way to say I'm right. And that's the process, just like that. At this point, there's an additional optional step called refactor, which is you look at your code and you say, okay, like it works, but could it be better? Could I only write one loop instead of two? Could I be less verbose with my if and else statements in a way that is still human readable? Are my variable names effective variable names? Do they convey meaning that a reader who maybe doesn't even code in the JavaScript language could understand and intuit what they're doing? Is my code efficient? Is it memory intensive, or is it using the minimal amount of memory that I would have to use? All these questions I can ask myself, excuse me, at this point, and I can choose to refactor. Before committing my code to version control, another thing I would do is delete all the pseudocode. I'll just do it for the function case, and then I'll undo it in case we need to save this. And when I do that, my code all of a sudden looks like it's supposed to, nice and clean. And then you wind up with the beautiful function you had wanted to write from the beginning when you started this whole long process all the way up here.
I'm having nightmares of the designer list from Premium Prep.
The fashion inventory list?
Yeah.
Classic.
Yeah, it's a lot like that one, right? That's funny, that made me laugh. Cool, I'm gonna open the chat now and see if there's any chatter going on that I haven't picked up on, because I haven't been looking. Does anybody have any questions at this point?
You mentioned earlier, I don't think it was for the for each, but you mentioned there was some method up there that was only good for arrays. Can you repeat what that was?
I can if you ask me from the beginning one more time.
Can you hear me?
Mention, yes, I just read the
Yeah.
chat by accident while it was, go ahead.
Oh, no problem. You mentioned, I think it was on the for each line. I don't think it was the for each that you said, but something you said only worked with arrays. What was that?
Oh, yes, so you all learned about higher order functions by building the underbar library. And one of the magic things about underbar, one of the reasons it came to be, is that it can do a lot of the work that some of JavaScript's native or built-in methods. It can do some of the work that those built-in array methods do on objects also. Underscore can handle collections that are arrays and objects in many cases, but it's emulating or reproducing those built-in methods that already existed before underscore ever came to be. And so some of those are like array.forEach, array.map, array.filter, array.reduce. In fact, if we just go to, whoops, underscore, not sunderscore, but underscore. Oh, that's not what I wanted. I wanted MDN for arrays. If you go to the array page on MDN, and you look in the sidebar, you're going to see a bunch of methods, all of the methods that exist on the array class. And you will find things like every and filter and for each, index of, map, reduce right, which is reduce in the opposite direction. I think Peter's writing a song about reduce. Ask him about it.
It's the higher order function you need.
He'll post it after this if you ask him to. It's a rap song. Sum, sort, these are all higher order functions. And so the magic about underscore is that it took the array prototype and said like, hey, we could do this to objects as well. And then it built a whole bunch of extra methods on top of it that are convenient. So that's all.
Hey,
Does that answer the question? Sorry, Sam, you're next.
yeah. You said, so we delete our pseudocode once we're done with the implementing it, but what if we need to change the function later? Wouldn't it be useful to have the pseudocode still there?
Sure. So you can you have options, and you don't have to follow what I said necessarily. If you're going to ship it to production, which means like this is going to be used by real users, then you delete the pseudocode.
Okay.
You don't add extra garbage to production. But if it's like your own educational repo, or it's just a thing it's still in development and you're not shipping this to users yet, you can keep your pseudocode. Or you could just grab each line of pseudocode like this. Oops, like this. And you can just bunch it all together, fix the indentation like so.
But if in a professional
and then
context, I'm
just-
sorry, go ahead.
And then you just pull it to the bottom.
Okay. Oh, of the everything. Okay, cool. Just below the function. But like in a professional context, it might be look unprofessional to have pseudocode, even if I'm passing it around the office or whatever.
Yeah, you'd look kind of like a noob.
Okay.
Your code should be so well written by the time you show it to others, unless you're stuck. If you're stuck and you're still working on it, you can keep your pseudocode when you show it to others. But I wouldn't go to somebody and be like, hey, I'm done. What do you think? And then it's littered with so many comments that it makes it look like you're not giving the reader the benefit of the doubt that they can read code, you know?
Okay.
Yeah, you want the code itself to be so readable. Like that's why variable and function names are so important. You should be able to read the code in a way that like, even if you don't speak JavaScript, you understand what's going on here. Like a Spanish person reading Italian or something. Okay, any other questions? Peter called it self-documenting code, and that is a fantastic term to learn. I'm not saying that comments in your code are bad, though. Comments are well-commented code is also good code, but you have to know what is too much and what isn't. And let's say group by was a good function name. It does make sense in the context where it's used. When you invoke group by, like people know what you're trying to do there. But there's some extra clarifying information that group by needs. Like this could be a good place to write, sorry, my pen's in the way, a short description of the group by function. Like that's a good spot. Or if there's a line of your code that's like that magic line that, man, I don't know really, I know it works. I'm pretty sure I know how it works, but like I know it took me 3 months to figure out this part, and someone reading this quickly is not going to know off the top of their head what I did here. Then you put a comment for sure. But you don't need every line to have a comment over it. That would look kind of weak. And just hard to read, frankly. Yeah, that's another good point, Peter. Peter's on fire today. If you need the comments in the code for someone to understand it on every line, it means you wrote really crappy code. Like it's not readable. It should be impossible to be confused in the presence of your clarity.
Woo, y'all heard that? Epic.
Any other questions? I stole that line. Marcus, the founder of Hacker, one of the 4 founders of HackerRector, said that to me like 4 years ago when I was being very unclear in a meeting. In a room full of people. Anthony, it would be better if it was impossible to be confused in the presence of your clarity, because what you just said was very unclear. Never forgot that line.
I want that framed in my office somewhere. That's hilarious.
Do you care more about readable or optimized? It depends. It totally, know your audience and know what you're trying to accomplish. If you are writing like firmware for a microchip to interpret, and it's the only one, like no one's ever gonna see this code except this piece of hardware that doesn't think or feel anything, then optimize, because that little piece of hardware probably can't handle the extra text and extra memory and whatever else that you're wasting. Know your situation. When I worked at Facebook, I worked in a company that had 40,000 engineers at the same time, all working in one monolith repo. Monolith means everything's in one repository, which is crazy to have something that big as one repo. And so at Facebook, you're measured by the impact you can make and the rate at which you can make that impact. And that's how they determine your bonuses and things like that. More on that in the next session. But it becomes really worthwhile to be able to ship code very regularly and very fast. And the bottleneck, though you might think it would be your ability to write code quickly, actually becomes, because you'll be too quick. What actually happens is your ability to get your code through code review, through the other members of your team, to get them to approve your code as you're trying to ship it, like that becomes one of the bottlenecks that will slow you down. Because when you write your code, you'll make a pull request, you'll ship it, and you'll say like, hey, teammate next to me, like, can you please review my code? And they're gonna go, yeah, I'll do that after the other 100 things I have to do today. I'll get to it at the end of the day. And then when they do, they're gonna mark it up like you did, like you got in your underbar or test builder repos if you shipped on time. And there's gonna be revision requests. They're not gonna just approve you on the first time. They're gonna be really picky and opinionated and mark it up. Red pen all over your essay. And then you're gonna have to take that and be like, okay, I have to fix these, make these revisions, and then you're gonna ask them for review again. And they're gonna say, I just reviewed you, I'll review this one tomorrow. I have 10 other code reviews to do today. And you wait 24 hours. And then they do the review tomorrow and you're like, wait a minute, I answered all your revisions. Why is there more comments on this? Like, oh, I thought of some other things you should do too. And so this very busy human who values their time very much, they looked at your code yesterday, thought of new things today because, not because they had an epiphany today, but because they're moving really quick when they're reviewing your code. It's not their major priority. And so if you are not very clear, they're gonna miss a thing or skip a thing. And so readability becomes the optimal thing to do for your personal productivity. The more readable your code is, the faster and more accurately they'll go through it on the first or second or third try, so that you don't have to go through 10 revision cycles just to get your thing shipped. And it's really on that order. At Facebook, I don't think I ever shipped a pull request in less than 5 code reviews, which was such a surprise to me. Most of them were like 10 or above. Side note, fastest way to increase that is to make smaller pull requests per thing that you ship. Ship the smallest possible amount of code at a time. And then it becomes impossible for them to have to go through it 10 times. I learned that too. But that's kind of off topic. So know your audience. Readable is good in some cases when you're dealing with humans. Optimization is most important when you're dealing with machines. And when you're dealing with both, you need a balance of the two.
So I have a question here. We used for each for this particular solution, but is there a preference like for using for each or using the each from underscore? Is there like, or does it really doesn't matter, or does it matter?
Honestly, it doesn't really matter. If you already have underscore like imported or installed into the project that you're working on, maybe you'll find that using the underscore functions are easier for you because it's your preference. It is largely a preference thing.
Okay.
The one thing that is important is that you're consistent. In
Okay.
your project, if you're going to use underscore each, then don't use for each somewhere else. Otherwise, you decrease the readability of your code.
Got it.
Yeah, make patterns and make order in your code. It's not enough for it to run. It has to be organized.
Okay. Thank you.
On that same thought process, if you get into a base and they're using one type of loop, you should continue that typically.
I want to say yes, as long as that is the appropriate loop to be using. Like sometimes maybe a while loop is better than a for loop, and so you should choose the while loop. Don't just use regular for loops when a for in loop is warranted. Use the appropriate loop, but if there's multiple styles of that same loop, like for each and each from underbar and a raw for loop, they're all the same loop, just with different names. So in that case, pick the same thing every time.
I have a question based on that too. What if we do use like the underscore loops and they don't have underscore saved or like on their system or whatever? Does that happen?
Do you mean like I wrote code and I used underscore and then I pushed it up to GitHub and my buddy cloned down my code and tried to run it on their local computer? That's what you mean?
Right. Yeah.
Cool. So you will learn very soon in the immersive about something called NPM. It's called the Node Package Manager. And when you use NPM, you get this special configuration file called package.json. Check this out. I'm going to turn this into an NPM-based project by just writing npm init. It asked me a bunch of questions. I hit enter to go through them, blah, blah, blah. Maybe I actually would answer them in real life. And then all of a sudden, my project got an extra file called package.json. And if I wanted to install underscore into this project, sorry, I'll give you my terminal back. Then I would just write npm install -- save underscore. And npm is smart enough to go into the internet, go to the npm database, grab the entire underscore library, and boom, download it directly into my project. And it's even smart enough to go into the package.json configuration file, make a new key called dependencies, and make this object here where the key is the name of the dependency that you wanted and the value is the version number. And so when you commit this and push it up to GitHub and your friend clones it down, this configuration file comes with it. And the very first thing they'll do is type npm install enter. And it just goes through the package.json dependency list and installs them all on your friend's computer. So there shouldn't ever be a case where your friend wouldn't have the dependency installed, because you'll have set it up for them to easily install immediately upon cloning down your code. If that was confusing, don't worry, it's going to be taught in the immersive quite soon, quite early in the immersive. So you'll learn about that very soon. If you have secret packages installed globally, that's cool for you on your personal use of your computer, but it would be bad practice to install a project's dependencies in your global NPM modules. Some good things to save there are things like the UUID module, because on your terminal, you might just want to use that package like this. Like I can type UUID, enter, and it just gives me a unique ID number, unique to any other one I've ever created before. And like, that's the thing I might want to do that's not specific to a project that I'm working on. I might just want that number right now. So I don't need that as a dependency of a project. It's just a global tool that I'm using. Or if I just want to run Mocha tests, I have Mocha installed and I can write Mocha group by.test.js if I had created that test file, and it would run my test code for me. But as soon as you start sharing code with others in a project way, like you should put all the dependencies in the package JSON. Any other questions? We got 93 people still in the room. Can I get a thumbs check in the chat? I will, the question is, from here forward, I will, great. From here forward, I will Venmo Anthony $5 a day.
They didn't wait to interpret the prompt. Look, they started.
Oh, look at all these people sending me $5 a day. Thanks, guys. You joined the subscription service. I'll give you a really complicated process to unsubscribe from the subscription that you'll never follow. The question is, will you use the problem solving process moving forward for every algorithm problem that you solve? Oh yeah, baby. Good, because if you don't, you will perish. You will lose. Follow this process. I promise it'll do great things for you, and it'll get you unstuck even when you feel like being unstuck is a thing you can't be. One more thumbs check. Was this a useful experience? This is the first time we've delivered this in pre-course. It was totally off the cuff, and kind of workshopping it to see if we should do it again in the future or make it recorded in a more formal way. Yeah?